Get ready to the countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Bismillahirrahmanirrahim. Hello there everyone. Assalamualaikum and a very good afternoon. Okay, welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah, and for non-Muslim, please recite your prayer according to your region. Okay, before we proceed, okay, how is everyone today? Okay, my prayer that everyone is doing fine and ready to proceed with today's class. I am Cikgu Hapsahayu from SMK Sultan Sulaiman, Kuala Terengganu. Your moderator for today, and together with me is our control host Cikgu Nun from College Matrikulasi Negeri Sembilan. Okay. And our observer Teacher Su from SMK Sri Serdang Selangor. And our important person of the day, our presenter Madam Rosmaya from SMKJ, SMK, SMJKU Hua Kajang Selangor. Okay, for the record, we are now live on Madam Rosmaya channel. So, as a sign of support to Madam Rosmaya for her hard work in preparing today's lesson, please subscribe her channel, not forgetting ours too. As usual, the lesson will last approximately for 1 hour, and please follow the class up until the end and give your full cooperating in making this session a lively one. Please take note that certificate link will be given at the end of this session. Besides this, don't forget to claim your credit for today's live class. Collect the credit to redeem the attractive prize in store. The link to claim the credit and the presenter username will also be given at the end of the session. However, please be alert to a letter and a 4-digit code to claim your credit that will be announced 1 digit at a time during the live class. So, get ready with your pen and paper. I would also like to remind students to use suitable language and profile picture if you wish to post comment on the chat box. I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. Okay, student, stay focused. And if you have any question, please write on the chat box and Madam Rosmaya will try to provide you with the answer. Okay, before that, this is a letter and a first code for today. Okay, A, egg. Okay, A, egg. Okay, without further ado, please welcome Madam Rosmaya.
Okay. Thank you to our moderator. Hi everyone. I am Madam Rosmaya. I'm a Form 6 teacher at SMJKU Kajang Selangor. And before we start, I would like to announce that now you all can download the Academy YouTuber apps already. Okay, you can just reach the search these apps at the Play Store and then type Academy YouTuber and download from there. So there are many PDPC videos, free tuition online class, and a lot more. It'd be much easier for you to do the searching by just using your fingertip only. Okay, so for those who are new here, I also would like to introduce the PU team in the Academy YouTuber. Okay, it's a collaboration team from STPM and matriculation PU teams. Okay, so this is a physics team. Okay, I am the leader. Okay, so all of us here, all physics teacher are here in the county except teacher Suhaya. Teacher Suhaya. Okay, so besides physics team, this is a maths team led by teacher Im. Okay, then we have biology pre-U team, okay, estimate and matriculation, okay, led by Cikgu Faiza. Okay, next is chemistry pre-U team, led by Cikgu Shahnon. Okay, and perakaunan dan ekonomi pre-U team, led by Madam Fizi. Okay. And besides that, we also have the STPM subjects, other STPM subject. Pengajian MURID, pengajian perniagaan, perakaunan for STPM subject. Okay, so now we continue with our objective for today. So topic for today is on circular motion. So we are going to solve problems on circular motion. So the problems or the exercise for this circular motion PDF posted already in the description part, or in the comment also got so you can get from there in the comment. Okay, you can get the PDF exercise from there. So the objective for today is you all will be able to learn the strategies in solving circular motion problems. And here are also shown here all the formula to memorize. So we have angular velocity equals to 2 pi f or 2 pi per t. Okay, frequency is 1 per t. And then velocity equals to r omega. Okay, omega is angular velocity. A, centripetal acceleration equals to v omega. And then F, centripetal force is mv omega. And also can use mr omega squared and mv squared per r. So you just substitute v equals to r omega into here. Then you get the three of the equation for centripetal force. Okay, let's begin our discussion on the first question. Okay, we start with the easy questions first. Okay, so those who've done this question, you can write there in the chat box. Write there in the chat box so that if you get it correct, maybe I can give a clap to you all. Okay, so question one. Question one. Let us read first. Federal guidelines suggest that the maximum safe centripetal acceleration in a turn is 1 meter per second per second. Okay, so find the minimum radius curve a civil engineer should design on a road where cars travel at speed 20 meter per second. Okay, so who here your ambition is to become a civil engineer? Can write there also in the chat box. In the chat box there, who likes to become a civil engineer? Okay, this is what one of the civil engineer do. So cannot just design a road. Means just design it. But with a calculation need to do. Okay, need to be done here. Like example in this question. Okay, so you can imagine the car in the turn here. Okay, so the acceleration is given, centripetal acceleration 1 meter per second per second. Okay, so that's why when we always see the engineer there, you use something that like camera here to measure something, do some measurement before they build the road. Okay, so now this is from top view. Okay, top view is the car here seen from top view. Okay, so the turn here, part of the circle. Okay, part of the circle with radius r. So we are going to determine this r. Find the minimum radius Okay, the acceleration is given by V omega. Okay, V omega, and the speed is given. So therefore, we can use speed V equals to R omega. So acceleration is given, speed is given. So you join these two together. Okay, substitute V equals to R omega into the equation here. Then you get the radius. Okay, so we get this acceleration, centripetal acceleration. This A is centripetal acceleration equals to V squared per R. Okay, so now we substitute the speed 20 meter per second and acceleration 1 meter per second and cross multiply. So you get R, radius of the turn here should be 400 meter. Okay, I can see in the chat box there, Teacher Im together with us now. Thank you for joining, Teacher Im. Okay, so this is the answer for question 1. So if you all get the same answer, can write there in the chat box. Okay, so we go to the next question. Okay, now question 2. Okay, let's read the question. A 57.0 kilogram ice skater is moving at 3.50 meter per second when she grabs the loose end of a rope, okay, the opposite end of which is tied to a pole. So you can imagine like this. Dekat the diagram not given, but I draw the diagram here so that you can imagine how the ice skater grab the rope. Okay, she then move in a circle, okay, of radius 0.600 meter around the pole. Okay, this is the pole. So find the force exerted by the horizontal rope on her arm. Okay, so what is the centripetal force? So actually this force is the centripetal force. Okay, so you are given mass and speed and then the radius. So there are altogether 3 equations of centripetal force. So which one to be chose depends on the given information. So because you are given speed V, so therefore we choose the first equation. F equals to mv squared per r. Okay, so radius also given. So we use the first equation. Okay, substitute everything. The mass of the ice skater is 57 kilogram. The speed is 3.50 meter per second squared divided by radius 0.600 meter. So you get the answer 1,164 Newton. Okay, so done for question 2. Okay, so how about this question? Anyone get the same answer as me or not? Okay, still not there, Teacher Ayu. Okay, so maybe they get the PDF exercise here quite late, so not enough time to do. But still okay, we can continue to the next question. Okay, next question. If you got any question to ask, also you can write there in the chat box. I can read it from here. Okay, so next question. Question 3. Okay, a 2,100 kilogram car moves at a roundabout of radius 20 meter. So if the road is flat and the coefficient of friction between the tires and road is 0.80, okay, how fast can the car go without skidding? So this means what? How fast can the car go without skidding? So that means the question wants to find velocity. Want to find velocity. Okay, so you are given mass, radius, and the coefficient of static friction. Okay, so what does this coefficient of friction here need to do with the equation just now, centripetal force? So there are altogether 3 centripetal force equation. Okay, you can imagine from side view, this is from top view. So from side view, so this is the roundabout, okay, this is the car. So the car has mass mg, so the direction of force is downward for weight. This is weight, downward. And we also have reaction force, okay, by the road, so upward direction. Okay, so therefore the centripetal force is provided by the friction. Okay, that's why friction is given. Coefficient of friction given. So the centripetal force is provided by the friction, lateral friction of the tire of the car and with the road, with the road. Okay, so no other force. Weight and reaction doesn't provide the centripetal force because it's vertical or perpendicular to the the circular motion here. For centripetal force is in this way, towards to the left, to the left. Okay. So along the centripetal force, we only have frictional force. Okay, so from the three equation just now, because we are going to find the speed, so again we choose the first equation. Okay, so this F is the net force or resultant force. So the resultant force involved here only friction, friction force. Okay, so that's mean Fr equals to mv squared per r. Okay, so now the friction force is given by mu r. Okay, this is a formula for frictional force. Okay, mu r. Mu is the coefficient of friction. Okay, and r is the reaction force. So equals to mv squared per r. So r is equals to mg. Okay, why r equals to mg? Because the car doesn't fly. The car remain move in the horizontal circle. Horizontal circular motion. So the car doesn't fly. So therefore r is equals to mg. So r equals to mg. So you substitute into here and you can cancel the m. So actually the mass of the car is not needed in the calculation here. Do you realize that? Not needed, the mass of the car. So you can cross multiply to get V. This is what the questions want. How fast can the car go without skidding? So the questions want V. So V equals to square root of mu GR. So we substitute everything. Mu given 0.80. G is 9.81 meter per second. And R is equals to the mg. Okay, so mg... this one R is the radius 20 meter. Okay, so you substitute everything and you get speed 12.5 meter per second. Okay, done for question 3. Okay, any question for this question? If got question, you can ask there in the chat box. I think this question considered easy, right? Okay, then we go to the question 4. Okay, question 4. Okay, question 4. A gorilla has mass 80 kilogram. Okay, tries to cross a river by swinging from 12 meter long vine. So his speed at the bottom of the swing as he just clears the water is 7.0 meter per second. So the gorilla doesn't know that the vine has a braking strength of 1000 Newton. So does he make it safely across the river? So justify your answer. So we are going to check whether the gorilla can safely across the river or not. So because of that, we need to determine the tension in the vine. Tension the vine holding by the gorilla. So after we find the tension, then we are going to compare with the braking strength of the vine. Okay, so the braking strength of the vine is 1000 Newton. Okay. Okay, so we use centripetal force here. Okay, can imagine like that. Okay, so the circular motion made by when the gorilla here hold the vine. So it make a circular motion. So I just draw the part of the circular motion. Okay. Okay, so this is weight. Okay, we have determine all the forces that act on the gorilla. Okay, so one of the force is mg. So another force is the tension in the vine. Tension in the vine. So just the two forces act on the gorilla. Okay, at the bottom end of the swing of the vine. Okay, bottom end of the vine. Okay, so from this three equation, so we choose one So V is given. So we choose the first one. Angular velocity omega is not given. So we choose the first one. Okay. So now this force is the net force, and the net force involved now there are two forces, tension and mg. So what is the centripetal force? Okay, so centripetal acceleration is somewhere here. So that's mean T is a positive and mg will be a negative. So we write here as T minus mg. So the resultant centripetal force will be T minus mg. Okay, so refer to the direction of centripetal acceleration to determine the sign of the force. So centripetal acceleration is somewhere here. Okay, because the circular motion is this way, right? So therefore T will become positive and mg is negative. So that's why become T minus mg. Okay, so now we solve for T, bring mg to the right side, become plus mg. And then substitute all the values. Mass of the gorilla is 80. Okay, speed is 7 meter per second squared divided by the radius of the vine. The length of the vine is 12 meter, and then mass again here 80 times 9.81. This one is the weight of the gorilla. Okay, total everything, we get 1,111 Newton. Okay, so the tension in the vine is 1,111. Now compare with the breaking strength. So the breaking strength of the vine is only 1,000. So the tension is larger than this value. So that's mean the vine cannot hold on. With this tension is larger, so the vine will break because of T greater than the breaking strength. So therefore, the gorilla cannot make it across the river. Okay?
Okay,
Pity.
madam,
Yeah?
can we share the second digit code?
Okay, the second digit code.
Okay, second digit code is number 8. Number
Okay, so
8.
number 8.
Okay.
Okay, jot that down. Okay, so we continue. Okay, so pity, the gorilla cannot make it safely across the river. Okay, so now we go to the question 5. Okay, question 5. The two objects P and Q move in circular motion with constant velocities. So object P has mass 2.5 meter and radius R1. And object Q has mass 4m. This one is m. For m, the object P has mass 2.5 m, object Q has mass 4m and radius 2r1. So if the centripetal force of these objects are the same, so find the ratio of velocity of object P to Q. So P first and then Q. So be careful this question. So P first and then Q. So diagram not given. So you are advised to draw so that you reduce your careless mistake later. So by just reading like this, maybe you can make careless mistake. So now you imagine the first object, radius for the circular motion is R1. So the velocity is Vp. So velocity of the object in the circular motion is always tangent to the point. So let's say this point, so Vp you see is tangent to the point and always perpendicular to the radius. Okay, then for the second object, the radius made is 2r1. Okay, so this is the direction of the velocity of object Q. Okay, so their forces, their centripetal force is the same. Okay, their centripetal forces is the same. So just choose one. So again here, the question's 1V, right? So angular velocity not given. So you use F equals to mv squared per r again. Okay, so now substitute everything. For Fp equals to, the mass is 2.5 m. Vp squared per R1, and for the Q, okay, FQ equals to 4m VQ squared per 2R1. Okay, so now you equate their centripetal force because mentioned here the centripetal force are the same. Okay, so you equate these two. So equate these two, we get this, and you can cancel the M. Okay, cancel the M and also cancel the R1. Okay, so the question's one ratio. So which one first? P to Q. So P first. So VP on top, VQ at the bottom. So VP per VQ, this is squared. So means on the right side become square root 4 per 2 times 2.5. Cross multiply here. And you get the ratio 0.89. So did you all get this answer? Okay, hopefully you get. Yeah. So if got any question, you can write there in the chat box. Okay, so now question 6. Now we go to question 6. Okay, question 6. A simple pendulum of length 1.5 meter is swung such that the mass goes round in a uniform circular motion in the horizontal plane. Okay, imagine like this. So the string makes an angle 37 degrees with the vertical. So what is the velocity of the mass in its circular path? Okay, so you draw the circle here. So choose one point. So determine, first step, always determine the forces that act on the object. Okay, so the forces act on the object are, we have the string here. So we have tension in the string. We have tension in the string. The string length is 1.5 meter. So the angle is 37 degrees with the vertical. So we have weight, we have tension. Okay. And then the centripetal force is provided by the what you call this? The component, the X component of the T, okay, tension. Because centripetal force is to the right in the circular motion here. So towards the center, centripetal force is direction of centripetal force is toward the center of the circular motion. So the force that provide the centripetal force is the what you call that? The component X of the T. Component X of the T. So the component X of the T will be T sine 37 degrees. Okay, T sine 37 degrees. Because the angle here 37 is opposite, right, to the length to the side here. So that's why we use sine. So just use trigonometric ratio. Trigonometric ratio. So for sine is opposite per adjacent. So that is where we get the component of T along the centripetal force for this circular motion. Okay, for the y component will be T cos 37 degrees, okay, which is equals to the mg. Okay, so now we form the equation for centripetal force. Okay, centripetal force T sine 37 degrees equals to mv squared per r. So only one force provide the centripetal force, tension, component X of the T. Component X of the tension. Okay, so this is one equation. Okay, next is the T cos 37 equals to mg. Okay, so T cos 37 equals to mg. Why? Because the pendulum, the simple pendulum remain motion horizontally. Okay, remain motion horizontally. So it doesn't fly, the string also doesn't break. So it remain move in horizontal circular motion. So that's why T cos 37 degrees equals to mg, the weight, balance, they are balanced, these two forces. So this is the second equation, first equation, second equation. Okay, and then the radius of the circular motion, okay, we also can use trigonometric ratio. So we use sine equals to opposite per adjacent. So we get r equals to 1.5 sine 37 degrees. Okay, so after we get all these three, then you can solve using the simultaneous equation. So the questions one's velocity, so velocity of the mass. Okay, so from these two equation, we use ratio because we don't want tension. We don't want tension, so we can use ratio so that we can cancel out t. So we don't need t value. So just 2 divided by 1. So we get sine 37 divided by cos 37 degrees. And on the right side is mv squared per r divided by mg. Okay, so you can cancel the m. Sine per cos is tangent. Okay, so tangent 37. And then cancel out m. So cross multiply to get v. So g times r times tangent 37. Then this is squared, v squared. So it becomes square root of gr tangent 37 degrees. Okay, now we substitute all the given values here. So g is 9.81. Okay, r is 1.5 meter. Sine 37 degrees. Remember, these are not the length of the string here, but it's the radius of the circular motion. So the radius of the circular motion is 1.5 sine 37 degrees. And then tangent 37. Okay, so you get 2.6 meter per second per second. Okay. Done for question 6.
Okay, madam, can we take a break for advertisement?
Okay. So we take a break now.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, we can continue.
Okay, welcome back to the physics free tuition online class. So we continue with question 7. Question 7. Okay, a small bit is set into circular motion in a horizontal plane within a smooth conical cone as shown below. Okay, so if the bit is moving with a centripetal acceleration g, so what is the angle alpha? So we are going to find this angle. So the condition is the bit moving with a centripetal acceleration of g. So the A, centripetal acceleration, is equals to the g. Okay, so look at the motion here. So first step, you need to draw the Cartesian plane so that easier for us to resolve the component of the forces. So next is determine all the forces that act on the bit. Okay, so what are the forces that act on the bit? So the famous force is usually the weight, right? So we have weight, mg. Okay, then because the object here, the bit here is moving in circular motion, so there must be a reaction force by the wall of the cone. Okay, by the wall of the cone. And mention here also smooth conical cone. So that's mean no frictional force. Okay, we can ignore the frictional force because of the word here, smooth, because of the smooth conical cone. So we just have R reaction by the wall here of the cone and the weight. So two forces only act on the object. So now look at the circular motion. So this is horizontal circular motion. So that's mean the centripetal force is horizontal, horizontal and towards x direction, to the right direction. Okay, so therefore the centripetal force is provided by the component x of the r. So we need to resolve the component r. mg, okay, so the weight of the bead doesn't provide the centripetal force because it acts downward and perpendicular to the circular motion. So it doesn't supply the centripetal force. So the only force that supply the centripetal force is component x of the r. Okay, so now we need to find the angle. So the angle here with the horizontal is alpha, same as alpha. Okay, how you know that? So you just use the form 1, form 2, form 3. Remember the method how to determine this angle. So we resolve the component of r cos alpha and r sin alpha. Okay, so we use trigonometric ratio. Okay, so how we get alpha here, actually we just do some revision, form 1, form 2, form 3 actually. So this right angle triangle bring here so that the diagram here don't look messy. So I draw it here. So this right angle triangle, so alpha there. So this is 90 degrees because right angle triangle. So the reaction force also is 90 degrees perpendicular to the wall. This is the wall. So therefore, the remainder angle here is 90 minus alpha because total angle in the triangle is 180. So therefore, the angle here is alpha. Okay, because 90 minus 90 minus alpha, so we get back alpha. Okay, so that's why the angle here alpha. Okay, this is the to recall what you've learned before in form 1, form 2, form 3 actually. So I purposely do this so that those who are still cannot get where the alpha the idea where the alpha come from. So this is how you get it. Okay, so now continue. Back to our discussion here actually to find the angle alpha for the centripetal acceleration equals to g. Okay, so now r sin alpha, the vertical forces up and down is same. Okay, so why they are same? Because the bead remain in horizontal circular motion. So it doesn't incline and it doesn't move at inclined circular motion, and it doesn't fly, and the wall also doesn't break. So it remain move constantly horizontally. So that's why upward force equals to downward force. So the upward force is r sin alpha equals to the mg. Okay, next, you can use the centripetal acceleration. So this is the circular motion. So acceleration is to the right. Centripetal acceleration is to the right. So therefore, r cos alpha is positive. R cos alpha equals to ma. So the A is centripetal acceleration, okay, towards the center of the circular motion. So this A is equals to this G, given that the centripetal acceleration is G. Okay, so now we combine these two equations. We can use ratio because r not needed. So we can cancel out r if we use ratio. Okay, so cancel out r. So we get sine per cos is tangent alpha. M also can cancel out. So now we get the equation tangent alpha equals to g per a. And this a, we can substitute the g here. Okay. Okay, this g substitute into the centripetal acceleration here. So therefore, tangent alpha is equals to 1 and alpha is 45 degrees. Okay, so easy, right? How to get the alpha? So alpha is 45 degrees. Okay, so that the centripetal acceleration here is equals to the g, which is 9.81 meter per second per second. So any question again, you can write there in the chat box. Don't be afraid. I can help you all with whatever problems come on in your mind. Okay, so now we go to the next question. Okay, so looks like I'm talking alone here. But it's okay. We go to question 8. Okay, question 8. Okay, we read the question first. Okay, a ball of mass m equals to 1.5 kilogram is performing circular motion around a cone. So this is a cone. So this ball is in circular motion around the cone. The speed of the ball is given 3 meter per second. Okay, length of the string is 4 meter. Okay, this is the string tied to the top of the cone here, and it's rolling or it's moving in circular motion around the cone here, horizontal circular motion. Okay, because the length of the string here is fixed 4 meter. So the ball must have performed a circular motion horizontally. Okay, so all surfaces are smooth. So what does this mean, smooth? So we don't have frictional force. Okay, then find tension in the string. Okay, mention here tension already. Tension, so that's mean one of the force is tension. Okay, so one other force is the weight. Okay, first step, determine all the forces that act on the ball. Okay, so we draw the Cartesian plane so that easier for you to determine the angle later. Angle given here, 35 degrees to the vertical. Okay, now we determine all the forces that act on the ball, downward, mg. And then we have reaction force by the wall of the cone, outside wall. So this time this way, because the cone is like this, not like the previous equation. So the ball is on the cone, outside the cone. So the reaction force is like is here. Okay, so now we need to resolve the component of R because one of the component of R will provide the circular, the centripetal force because the circular motion is horizontally here. So that's mean the one component of the R, which is X component, will provide the centripetal force. Okay, so another one forgot. We have tension in the string. So three forces act on the ball. Okay, I forgot about the string. So we have tension, reaction force by the wall, and mg. Okay, so now to resolve the component, so we need to find the angle. So this is 35. Here also 35 because it's alternate angle. Okay, remember you've learned in form 4, form 5, right? Maths. Okay, this is alternate angle, so 35 degrees here. Okay, so we resolve the component of tension in the string. We have T cos 35 degrees. So use trigonometric ratio and T sine 35 degrees. Okay, so for the reaction force also same. Angle here is 35 degrees. So how to know this 35 degrees? So again here, we can make the line here cross along the what you call this, the string. So you projected the line here. Then the angle 35 here also 35 because this is alternate corresponding angle or cross angle to 35 here. Okay, it's the same 35. So that's mean the angle here is 90 degrees, right? X and Y axis 90 degrees. So the angle here will be 90 minus 35, and therefore reaction force is also perpendicular to this projected line just now from the string. So therefore here also 35 degrees, right? So that's how you got it, the 35 degrees here. Okay, so we resolve the component of R. So the component of R will be R cos 35 degrees and R sine 35 degrees. Okay, the component. Okay, so now we form the equation. We can use balance forces because the object, the ball here remain in horizontal circular motion. So all the upward forces equals to the downward force. We have one only downward force because the ball remain in horizontal circular motion. Okay, and then one more equation is from the centripetal force. So the centripetal force are provided by the two forces here, horizontal force, T sine 35 degrees and R cos 35 degrees. Remember that from the three equation, we have the component T sine 35 and R cos 35. Okay, so we we write first the upward and downward force. Upward force is T cos 35 degrees and R sin 35 degrees. So these two forces upward direction considered positive and it is balanced by the weight downward. So equals to mg. Okay, so balance. I repeat, why balance? Because the horizontal circular motion, because of the horizontal circular motion. Okay, the ball doesn't fly, the string doesn't break, right? So it remain in circular motion. So the both forces balance. Upward forces equals to the downward force, which is weight, which is the weight of the ball. Okay, this is first equation. The second equation, we use centripetal force equation. So centripetal force is provided by the T sine 35 degrees, which is positive, because T sine 35 degrees is towards the center, acceleration is toward the center of the, what you call this, center of the circular motion. This is centripetal force, centripetal acceleration. So this way, so that's why T sine 35 degrees is referring to the direction of the centripetal acceleration. That's why it's positive. Okay. And look at R cos 35. R cos 35 is opposite direction. That's why it is minus. Okay, so we put minus there. R cos 35 degrees is to the right. So that's why it's minus. Okay, so now the radius of the circular motion, we can use trigonometric ratio. Okay, R equals to 4 sine 35 degrees. Okay, so we use sine 35 degrees equals to the opposite divided by hypotenuse, which is the length of the what you call this, the string, the string. So cross multiply, you get R equals to 4 sine 35 degrees. Okay, so use simultaneous equation for equation 1 and equation 2. The questions 1, tension. Okay, tension in the string. So from 1, you rearrange the equation, becomes R sine 35 degrees equals to mg minus T cos 35 degrees. So actually it's up to you. Just use simultaneous equation. So I just use one of the method to solve for tension in the string. So I want to cancel out R. So I put R as a subject here. So bring T cos 35 degrees to the right side. Equation 2 also I do the same. So R cos 35 degrees bring to the right side, and mv squared per R bring to the left side, become minus. Then exchange the position. Okay, this one is from equation 1 and equation 2. I rearrange the equation like this, and I get I get the ratio, so that I can cancel the R. Okay, get the ratio, and the sine per cos become tangent. Okay, right side, so mg minus T cos 35 degrees divided by T sine 35 degrees minus mv squared per R. Okay, so cancel the R, sine per cos become tangent 35 degrees. Okay, so right side remain the same. Okay, so now it's time to substitute all the values. So we calculate the R first. R is 2.294. We can substitute into here later. Okay, now continue. Okay, we want T, so we put T as a subject. Cross multiply this one times tangent 35. Okay, you can substitute at the earlier stage or at the final stage. It's up to you. Both can give you marks. Okay, so I cross multiply first. I make T as a subject first so that easy to solve. Okay, so now substitute, expand the bracket. And arrange the T on one side. So factor out T because we want T. So factor out T. So bracket will be sine 35 tangent 35 plus cos 35. Okay, right side remain the same, and you calculate. You get, you bring this to the right side. Okay, finally, then only I substitute everything here. 1.5 kilogram. The speed, 3 meter per second here. The length is in here, R, already. So 8.7 Newton. So the answer is 8.7 Newton.
Okay.
Okay.
Okay, madam.
Yes.
We share the third digit.
Okay, the third digit
Okay,
code.
third digit code is number 8.
Number 8 again.
Eight. Eight
Okay.
again.
It's very nice number.
Many egg. Okay.
Okay, now
can
we
continue.
continue. Next question. So next question. Okay, question 9. Okay, the figure shows a Ferris wheel, okay, which has diameter of 155 meter and takes 1 minute to complete a revolution. Okay, a person of mass 60 kilogram takes a ride on the Ferris wheel. Okay, so calculate the angular velocity and the speed of a basket of the Ferris wheel. Okay, show on the diagram the forces on the person when he is in basket A and basket B. So basket A on top, basket B is at the bottom here. Okay, then calculate the reaction of the basket on the person in each of the basket A and basket B. Okay, so we do question A first. Okay, calculate the angular velocity. So angular velocity is omega, given by the symbol omega. So from the equation, A equals to V omega. Uh, okay, so given here 1 minute to complete a revolution. Okay, so we can calculate angular velocity from here. 1 minute to complete a revolution. So that's mean one complete revolution, it gives you 1 minute. So this will be the period. The period. So angular velocity equals to 2 pi f, and f is frequency, is equals to the 1 per t, period. T is period. So you can find angular velocity. Omega is angular velocity. Substitute the 1 minute, convert to second. So you get angular velocity 0.105. The unit for angular velocity is radian per second. Okay. So this means period. The time, because this is time taken for one complete revolution. A revolution. So it is understood that this is a period. Okay, done for question 1. Then we go to question 2. We are going to find the speed of a basket of the Ferris wheel. So the speed is tangent to the point on this circular motion. So the speed is constant, but it's in the circular, it always change direction only, tangent to the point. Okay, so we use the relationship between angular velocity and the speed. Okay, because you calculate angular velocity already. So we can use V equals to R omega. R omega is angular velocity. And this one is not W, okay? This is omega, symbol for angular velocity. Okay, so now we substitute the radius, given diameter 155 meters. So the radius will be 155 divided by 2. So angular velocity just now is 0.105. So you get the answer 8.114 meter per second. So this is the speed of the basket. Okay. Okay, done for question A. So we go to question B. Okay, question B. We are going to determine, to draw, okay. Show a diagram, the forces. So for basket A on top, basket B at the bottom here. So the person, this is what the person. Okay, the person inside the basket will give a reaction. The base of the basket will give the reaction force. So let's name it as RA because it's on top. This is basket A, so we name the reaction force as RA. So this is the reaction by the base of the basket. And one more is weight. Okay, two forces only act on the man, act on the person, on the basket. Okay, at the bottom on basket B, so the reaction force also upward. We name this as RB. Okay, because this is from basket B. But the weight of the person still the same, mg. Okay, mg. Okay, done for the forces shown on basket A and basket B. Okay, shown here. Okay, now we are going to calculate this reaction R, this RA and RB. Okay, so next calculation part. So from these three equations of centripetal force, which one to be choose? So we choose mv omega. because here V you know already calculated already in A, right? V and omega. So we choose second equation easier. You can still choose the top one, or the second, the third, the first and the third. The answer will be the same. So no problem. But for the reference here, I'm going to show here the calculation now. I chose the second equation. So F equals to mv omega. Okay. So the acceleration is downward, the centripetal acceleration, so towards the center of the circular motion. So mg will be positive, mg will be positive and Ra will be negative because opposite of the centripetal acceleration direction. Okay, always refer to the centripetal acceleration direction. Okay, so mg will be positive, Ra will be negative. Okay, now you can solve for Ra. So bring mg to the right side. Rearrange this and become Ra equals to mg minus mv omega. So factor out m, so g minus v omega, and substitute all the values into the equation here, and we get Ra is 537 Newton. Okay, 537 Newton. Okay, then for we do the same for the basket B, but this time, okay, look at the RB direction. RB direction is same direction as the centripetal acceleration. Okay, at the bottom here, the centripetal acceleration is upward. So therefore, RB is positive this time. RB is positive, whereas MG is negative. So RB minus MG. Okay, RB minus MG. So RB equals to MV omega plus MG. So substitute all the values here. So you get RB 640 Newton. Okay, so done for RA and RB. Okay, so RB will be larger than RA. Okay, compare these two. Okay, so that's why the person will feel heavier here and at the bottom here. Okay, now we go to the question 10. Okay, last question I give to you in the exercise, PDF exercise. Okay, question 10. A particle is suspended from a point X, okay, this is point X, by an inextensible string of length L. It is projected from Y with a velocity U, okay, perpendicular to XY, so which is just sufficient for it to reach point Z. Okay, show that if the string is just taut when the particle reaches Z, its speed at Z is given by V equals to square root of GL. So L is the length of the string. Okay, we are going to show this. Okay, so we do question A first. Okay, question A. So from these three equation, we again choose the first equation mv squared per r because we are going to prove this V. This V, so we choose the first equation. Okay, the centripetal force is provided by the, okay, so we have tension in the string and also the mass of the object, the mass of the object. So we have weight and we have tension, not mass, weight of the object, mg, and the tension in the string. So two forces will supply the centripetal force. So this F is the net force, centripetal net force. So mg and tension is both directed towards the center, same direction as the acceleration, centripetal acceleration. So therefore, both of them is plus, positive, T plus mg. Okay, look at the direction of mg and T. So it's T plus mg. Then you substitute the radius of the circular motion, which is equals to the length of the string, L. So divided by L. Okay, the A direction is downward. That's why T and mg is positive. Okay, so the string is just taut. So that means the tension in the string is 0. So this is the hidden information we get from here, the statement here, taut. So the string is just taut. So that means tension is 0. Okay, then you can solve for the V. So cancel the M. So it is proven that V equals to square root of GL. Okay, cross multiply here. So proven that V equals to square root of GL. This speed at the peak of the string when the string is just stopped. Okay, now we go to question B. Question B, use the principle of conservation of energy to show that the speed u with which the particle is projected from y is given by u equals to square root of 5gl. Okay, now we are going to prove the u here, initial velocity at this point y is given by square root of 5gl. So the question guide you already to use principle of conservation of energy. So we use principle of conservation of energy. Okay, so total of energy at point Y here is equals to total of energy at point Z. So we assume there is no loss of energy. So equate then. So at Y, the energy involved here is kinetic energy and potential energy. Okay, so kinetic energy, total of kinetic energy and potential energy at Y equals to total energy and kinetic energy and potential energy at Z. So equate them. So you use the formula kinetic energy half mv squared and potential energy mgh. Okay, this is the formula for kinetic energy and potential energy. So ky will be half mu squared because here is u, half mu squared. So the potential energy at y will be 0. Okay, at z, the kinetic energy will be half mv squared and the potential energy will be mgh. So the h will be diameter of the circular motion. So the diameter will be L plus L, 2L. Okay, so now we solve the V at the peak here when the string just stopped is given by square root of GL. Okay, so we substitute this into here. Then we solve for the U. Okay, M all cancel out. Then we multiply by 2 all the terms here. So we get U squared equals to GL plus 4GL. 2 times 2 is 4, right? So the U is equals to square root of 5GL. Okay, proven or shown. Okay, that U at the point Y is 5G, square root of 5GL. Okay, then from here we can calculate C, tension in the string. Okay, tension in the string, we use centripetal force. Okay, we use centripetal force at point Y. So at point Y, okay, we choose F equals to mv squared per r. So at point Y, we have tension in the string and then mg is downward. So therefore, T will be positive and mg will be negative because centripetal acceleration is upward. Upward here. Centripetal acceleration upward. So T follow the positive sign because follow direction of centripetal acceleration, and mg will be negative. So T minus mg equals to mu squared per r. So u calculated already in B, so you substitute the u into here. So u squared will be 5gl and we can cancel out L and we get T equals to 6 mg. So that's the tension in the string when the particle is at the lowest point Y. So done. And I will leave you one question for you to do at home, and I will make a video out from this. Okay, using question 10 actually. This is the harder question a little bit from just now. So question 11 and question 12 here. So you can refer to this video, back to this video to calculate question 11 and question 12. Okay, so you do this too, and I will make a video out of these two questions. Okay, so now I give back to to our moderator, teacher Ayu.
Okay, Alhamdulillah. Okay, we have reached the end of today's session. Okay, thank you, Madam Rosmaya, for preparing today's lesson, and congratulations to those who are able to follow our live class from the beginning till the end. Okay, again, student, let's thank Madam Rosmaya by clicking the subscribe button and activate the icon bell so that you will not miss the next live class. And also don't forget to hit the like button. Okay, the last digit code is number 6. Okay, number 6. Okay, now you have all a letter and 4-digit code to claim your credit. Okay, the certificate link and the link to claim the credit are already in the chat box. The certificate and credit link are given as a token of thank you for your dedication in joining the free online class today. And please share today's live class to your friends and your social media. Okay, spread and share the goodness. Okay, please take note, the credit link will end 15 minutes while the certificate link will end half an hour after this live. Okay, make sure to use the EDD email or MOE email or myguru.edu.my or jawi.edu.my only. Okay, to log in. Okay, incorrect email use will not be entertained. Okay, if you wish to get more information on the online class, go to www.academyyoutuber.com. And to those who haven't joined eDidik Junior Telegram, please do so. Don't forget to join our live class next week, Sunday at 5 p.m. Okay, till we meet again, ingat hashtag bermula percuma, selamanya percuma. Stay safe and be safe, student. Assalamualaikum and bye-bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.